A couple of days ago, a question came up in the MSDN forums on how to detect whenever someone is shaking a Windows phone vigorously to the left or right or up and down. And so I decided to make a class that would detect just that. And whenever it detects such motion, it's going to raise a shake event. So I gave this class a number of settings so that someone could fine tune how it works. For the most part, I've decided to define a minimum acceleration magnitude. So in other words, if someone is shaking the device very gently, it's going to ignore that unless the magnitude of acceleration that they put on it exceeds this level. You can also define how many times that the device has to be shaken in order for it to be detected. By default, they need to shake the device, or it needs to detect two shakes. So if I were to move it to the left and then move to the right and back to the left, when it's changing directions like that, each each time it changes direction, that can constitute a shake. So going from not moving at all to vigorously moving in one direction will count as one shake. But then when I change direction, that's the second shake. And if I were to increase this number, which can also be passed through the constructor, then the number of shakes that the person would have to do would have to also increase before this class detects it. And so when this class is started, it doesn't do very much. It just creates a new accelerometer instance, will subscribe to its events, and then it starts the accelerometer. Likewise, the stop method, I'm not going to go into it. It just stops the accelerometer and releases its reference to the accelerometer. Now, I normally like to work within radians, but since others are going to be consuming this code, I decided to go ahead and work in degrees. So let's go down to what happens when the accelerometer throws out a reading. First thing I do is to check to see whether or not this reading is even in the magnitude range of the readings that I care about. If it is, then I go ahead and I get the angle at which the device is accelerating. I change that angle from radians to degrees. And then after I have, I change it from radians to degrees. And after I have the angle in degrees, I change it from degrees to a direction. Direction is an enumeration that I defined. Just to show you, let's see, and where is it? Here it is. Just to show you, I decided to go with the directions on the map as the names for each one of my directions. So north, east, south, west. I think most of us are familiar with how those are oriented on the map. So those you should be able to interpret those without further explanation. So once I have the direction, I check and I see if this direction is opposed to the last reading that I took. If it's in the same direction as the last reading that I took, then it's not something that I really care about. The device hasn't really changed direction. So at that point, I just return and I don't do anything else. But if it is in a different direction, then I go ahead and I create a new shake record. And all our shake record contains is the direction in which the device is moving, along with the time at which that reading was taken. So I go ahead, create a new record, grab whatever the current time is, and grab the direction, and I save this into this list. In this list, its size is always going to be equal to the number of shakes that I said is necessary for this class to detect something. And this list will wrap around. So as new records are being created, as it gets to the end of the list, it'll wrap around to the beginning. And after I've taken that record, then I go ahead and I check to see if there's any shakes that have occurred that I care about. And all the check for shakes method does is it'll look at the last record within my list and the first record within the list. And it checks to see if those shakes occurred within whatever the time threshold is that I define. And if it is, then okay, we've detected a shake, so I'll raise my on shake event. One thing to keep in mind is the accelerometer raises events from a different thread. So if you're changing anything on your UI, you're going to need to marshal that over to the UI thread. And to show you where I've done that, this is the code for my main form. You can see there's not a lot of code in here. Within the constructor, all I did is I created my shake detector, subscribed to the event. And within the event, I wanted to start an animation. So in order to make sure that this occurs on a correct thread, I call the dispatcher's begin invoke method, and it'll take care of moving that over to whatever thread is necessary before it executes the code that I give it. And all this does is it grabs onto my shake animation, and it will start playing the shake animation. And for my shake animation, I decided to just, I have a circle on the screen, and it will change the circle from white to red. And I will show you the layout of the program looks like. This is pretty much it. Actually, I should have called this an ellipse, not a circle. So the only thing that I added, other than the default XAML that you get, is the ellipse shape. And then toward the top of the XAML, there's a color animation that goes from red to white. So next I'll demonstrate this program working. I decided to make use of color in demonstrating this program because it was the easiest change that I thought I could show on film. So whenever I start to shake this, you see that it changes red and then it fades back to white. And so this is just a demonstration of the code that I showed you. And note that the code was only looking at things along the XY axis. If I start to shake the device back and forth, it doesn't detect that. Only if I do it left and right, up and down, or some combination of it.